Hi, this is Waqar. I am PhD student at Italian Institute of Technology. It is my pleasure to introduce our work Cleaning Noisy Labels by Negative Ensemble Learning for Source-Free Unsupervised Domain Adaptation. Deep convolutional neural networks have shown remarkable achievements in a variety of tasks. However, to perform well, training and testing data are assumed to be drawn from the same distribution. This is unrealistic when the system needs to be deployed in a real-world scenarios. Consequently, a model trained on a source domain often fails to generalize well when it is deployed on a related but different target domain. This happens due to a well-known problem called domain shift. Since annotating data from every possible domain is expensive and sometimes even impossible, unsupervised domain adaptation methods seek to address such a problem by minimizing discrepancy across the domains without accessing the target label information. However, conventional unsupervised domain adaptation methods presume source and target data to be simultaneously available during training. Such an assumption may not hold in practice as source data is often inaccessible, for example due to privacy reasons. On the contrary, a pre-trained source model is usually available, which, as discussed, performs poorly on the target domain due to the well-known domain shift problem. This translates into a significant amount of misclassifications, which can be interpreted as structured noise affecting the inferred target pseudo-labels. Therefore, in this work, we cast unsupervised domain adaptation as a pseudo-label refinery problem in a challenging source-free scenario. To this end, we propose negative ensemble learning technique, a unified method for adaptive noise filtering and progressive pseudo-label refinement. Our method is devised to tackle noisy pseudo-labels by enhancing diversity in ensemble members with different stochastic input augmentation and feedback. The latter is achieved by leveraging the novel concept of disjoint residual labels, which allow propagating diverse information to the different members. As a result, a model trained with the refined pseudo-labels leads to a robust performance on the target domain. Our method works as follows. In each iteration, a batch of target samples with different augmentation is fed to each ensemble member. Next, considering the inferred pseudo-label, different feedback is backpropagated by leveraging disjoint residual labels with negative ensemble learning loss. This allows each member to learn diverse characteristics from data, which is possibly complementary, leading to a superior noise resilience and a stronger consensus leaning towards the actual class label. In particular, this is how pseudo-label refinement is done over the course of training. In the beginning, almost all the samples are predicted with very low confidence. Next, as the network starts learning, noisy samples are segregated in the low confidence interval. So, only the samples carrying confidence lower than gamma threshold are reassigned with the possibly cleaner pseudo-labels. In the figure, the profiles related to the right y-axis in the dashed lines show the capability of threshold gamma to adapt to different single-sourced unsupervised domain adaptation cases, while the profiles related to the left y-axis show the corresponding noise reduction. In particular, it is worth noticing that no pseudo-label refinement is applied during the first few epochs until the ensemble gets a mature state of generalization capability. As the ensemble members get more and more confident in the clean examples, label reassignment becomes more rigorous, preventing the model to overfit to the noisy samples. To summarize, in this work, we cast unsupervised domain adaptation as a pseudo-label refinement problem in a challenging source-free scenario. We propose a negative ensemble learning technique which takes advantage of different data augmentation and feedback using disjoint residual labels to diversify the learning of ensemble members. Thank you for your attention.